So we're going to play a little bit here with string and characters. They're really just another data type. A character is just a single letter, number, space, so just a K by itself. If you look, it's a 1 by 1. A string is just a list of characters that may or may not make any sense. And if you look at the size of it, it's just a 1 by 17. You can see that in the workspace as well. So it's just considered a matrix of characters. So I can do things with it that I could be like K at the location 3 is equal to, star, and then it would just do that. So you could do stuff like that, which I don't know why you would do it, but whatever. You could, just treat it like any other kind of, whatever you call it, Matlab matrix that you wanted. You could be like K at end plus 1 equals, exclamation point, and then you've got Matlab is awesome. So, just from a basic level, that's what strings, the difference between a string and a character is just an individual element. A string is a matrix of those characters. Now, where things can go wrong, and really never in your life is anyone going to ask you to do the math we're talking about doing here. The reason we're doing the math that we're doing here is because that one day you're going to be doing something and you're going to get weird answers. You'll be like, where are these stupid answers coming from? They make no sense. And then you're going to remember this stupid video and be like, oh, dang it. That's right. Okay. So, remember when we had this thing where we would say, I ate blah, blah, blah bags of Skittles. And you're like, oh, that didn't work because it said I ate $ bag of Skittles. So I just say, I ate, and we had to do like num to string x bags of Skittles. And we just got used to it. We moved on with our life. Okay. So if you remember why this happened, it's because there's this thing called the ASCII table. So if you go over, I'm not online right now, but if I go over, I made an ASCII table. I actually made a print ASCII table. If you want to look at, this is my code that prints an ASCII table, because I am soups cool. But this is my little ASCII table that I've printed out for myself. It's not very big. But if I said I ate how many Skittles? 36 Skittles. So if I ate 36 bags of Skittles, I'm going to put this over here and make this smaller. If I ate 36 bags of Skittles, I can see that 36 corresponds to a $. So that's why it says I ate $ bags of Skittles. So there you go. And whenever you do this, you end up with nonsense things. And this happens to programmers. We do things because we're not paying attention, because we come in, somebody else had written this code before you, they have the numbers 7 and 8, and you're like, okay, I'm going to do something, I'm adding these two numbers together, and you're like, I'm getting 111. Why? Why am I getting 111? This doesn't make any sense. And your brain explodes, and then you remember this, and then you're like, oh yes, I remember this video. I remember doing homework problems where I was doing stupid ASCII math. And again, nobody in real life is going to have you do ASCII math. We're mostly having you do ASCII math so that you remember that ASCII math is a thing, so that whenever you're making programming mistakes, you know why you're making them. I don't have a better explanation than that. We're making you make mistakes on purpose so that whenever you get bad code that does bad things, you remember that this is a mistake that's super, super common, so that you can remember to fix it, I guess. All right. So anyway, if I add 7 and 8, I clearly get 111. Because if I go over here, 7 is 55 and 8 is 56. So 7 is 55, 8 is 56. So 55 plus 56, clearly 111. You can actually do some more fun if you wanted to do a number like 50, oops, I don't know why I put it in there, 55 and y equals 33, and z equals x plus y, you get 104 and 104 because it's adding the numbers 5, which is 53, plus 51, 53 and 51 is 104. Yeah, so it's adding them by column. So if I'm like 57 plus 32, I'm getting 104 plus 105 because 7 is 55 and 2 is 50, so clearly that's 105. Isn't this great? Yeah, it's pretty fantastic. So anyway, this is just another one of those lovely things that you can play around with and learn. It's just one of those things that we like to show you guys so that, again, whenever you're playing with code and you're doing stuff, a lot of people like to do, for example, a thing with the input statements. What or how much did you eat? And then just for simplicity, they like to save things as a string so that if somebody puts in, characters, they don't get an error. But by saving the input as a string, now that number is going to be created as a string. So if you try to, multiply it by something, you're going to be multiplying not the number value, but the string value. So that's really why we're doing this, is specifically because people do things, and we're trying to save you from yourself. So in case you need it, there are things called double and char. So I'm going to close this, it's bothering me. So there's double and char. So if I go double of 7, that will give me the ASCII value of 7. If I wanted to know in retrospect, or what's the char value of 55, it's going to come back and tell me 7. So double is going to tell me the double value, and char is going to go backwards. So double and char are kind of like inverse functions of each other. If I double char 55, I'm going to get 55 back. And if I back. And if I char double 7, I'm going to get 7 back. Okay, so I don't know if that helps, but double and char are are functions that you can use in Matlab if you, for some reason like me, don't have internet right now, or are pulling up the ASCII table. And I think that's actually what I did in my ASCII print table thing. I used char. Yeah, I used char to get that value. So, okay, so we got that. Now, if you really did want to add 7 and 8, you can use string to num. So, and I think it wants you to do string to double for faster performance. Again, this is not taking an excessive amount of time. So if you want to do string to double, you can. So string to num will convert 7 to the number 7. String to num will convert 7 or 8 to the number 8 and give you 15. Just like it did up here when we were string to numbing to get the 36 bags of Skittles, because we wanted to see, or I guess we nummed to string. Sorry, we nummed to string up there so you can string to num to get the opposite kind of effect. So yeah, so all that said, where this is coming to is, if you can do this without running it, then that means this kind of has made sense. So this is kind of the worst case scenario of how we could possibly do ASCII Math. So I'm going to try super duper hard not to hit Control Enter here. So I'm going to pull up my ASCII table and kind of walk you through this a little bit and see if we can work on it together. So, come here, girl. Chirpy, chirpy, chirps. All right, and then chirpy, chirps, 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 chirps. Okay, so V is actually the character V. Okay, so the character V is the number 118. Okay. W, the variable, is the character Y. The character Y is 121. Okay. The variable X is the character 8. Character 8 is 56. Okay, Y equals 3. Let's not overthink this. This is 3. Okay, like, it's not the character 3, it's just 3. And then Z is the character 9. So Z is, wait, no, that's Z the variable, not Z the character, is the character 9. So that's 57. Okay. All right. So let's see. So I've got v plus v the variable, plus v the character. Okay, v the variable is v the character, thank you, plus v the character. V the variable is 118 and v the character is 118 and v the character is 118, and I don't know what 118 plus 118 is, so it's 236. Okay, so that should be 236. We're going to come back and check these. Okay, so x the variable, that looks weird, x the variable is 8. Okay, x the variable is 8. And then x, the character, okay, so x, the variable is 8, which is 56, and x, the character, is 120, and then 56 plus 120 is 176. Because I would do everything else right, and I'm going to get that part wrong. All right, this one I think is going to be a little bit easier. String to num. I'm going to take the string and convert it to a number 8. String, convert it to a number 9. Okay, I got that one. Whoops. Spoke a little too soon. Okay. Z, the variable, which is the character 9, plus, okay, this is, and if you think you know what's going on, pause the video and work ahead and see if you can kind of get this. Okay, plus the character y is 121, plus the character w, which is 119. Okay, so that's, I guess I should have done that differently. So the character 9 is 57. So that's going to be 57 plus all that, and I'm too lazy to do the math, so it's 297. I hope. Please let these be right. Okay, so now this is the variable y, which is the number 3. Hot damn. Plus 7, which is the character 9, plus string to num, take the string of the variable x, which is 8, okay, plus 8, okay, so it's 3 plus the character 9, and I know I've already gotten this written here, it's just helping me, I'm just triple checking everything, plus 57 plus 8, please tell me that's 68, that should be 68, right? Yay, look at me, I can do math. Okay, and then the double of v. Okay, so the double is the decimal version of this variables thingy. So the variable is v, so the double of v, that's going to be 118. And the variable of x is 56, I think. I think that's the one I'm like the most nervous about. 174. All right, let's see if we got these right. Gonna hope. Okay. 236, 176, 17, 297, 68, 174. We are amazing. Okay, so if you can do that, you're phenomenal. But that's walking you through it. That's just the basic way of, can I clear the output? Yeah. Okay, so it was a little hard to see. So looking here at what we did is just taking it kind of a step at a time. Be very, very, very careful. V, the variable, which happens to be also V, the character. X, the variable, which is 8, the character, plus the character X. So why are we being obnoxious? We're being obnoxious because what we're trying to do is we're trying to teach you how to stare and process and be so super picky, because that's how you write good code. Is it's this one stupid number, letter, function, line that you like move the line 2 lines over, and now all of a sudden your code works. We're trying to teach you how to be just super precise, and that's why we're showing you how to do this. So if it seems like this is a really stupid exercise, no one's going to ask me to do this in real life. Well, I hope not. I hope nobody ever asks you to do this in like an actual job. Mostly because, a computer could do it. But we're really trying to make sure that you understand. This is demonstration that you really understand what's going on. So anyway, ASCII Math, it's a pretty standard thing for people to ask students to do. So I hope that this helped clarify some of that.